Hi, today we're going to be learning about converting mechanical energy into electrical energy. What have we learned so far? Well, so far we have learned that using a bike we can create rotational mechanical energy. This can be expressed in watts. We have also learned about electrical energy in terms of volts, amps, and current. This can also be expressed in watts. Why are those the same thing? Because they're not, right? They're two different things. Well, actually, we can use something called a generator to convert between the two. I've got a little diagram here. A generator is a device that has a pulley wheel on it. When that pulley spins, a coil of wire inside of it spins around a little magnet. When a coil of wire spins around a magnet, we have what's called an electromotive force. When that happens, bam, we have electricity. But how do we spin that wheel? We use a bike, the bike you see in front of you. You see, when we pedal the bike, the back wheel spins like this, which normally pushes us forward on the ground. But if we lift that bike up in the air, like the one you're sitting on, and we put this pulley onto it with a belt, that bike tire spins, and then this spins the pulley of the generator. Now we can spin that coil of wire around that magnet and get our electromotive force. And if we spin the pulley fast enough, we can create enough electrical power from the electromotive force of the magnet to light up light bulbs, charge a battery, charge your phone, charge those AA batteries for the controllers in the Xbox at the Boys and Girls Club. We can do a lot of different things. Actually, as you'll see on the front wall, anything that can be charged with a USB can be plugged into that. Bam! You've got electricity. Let's take a look at our physical exhibit now so I can show you how exactly your mechanical energy is getting converted into electrical energy. Before getting on the bike, make sure that the large switch on the left is set to setting 1 for the lights, and that the smaller switch on the right is set to setting 2 for the LEDs. As you begin to slowly pedal the bike, you'll notice that the lights start to come on. And at the same time, this green meter will start to show you a voltage output. This is your mechanical energy getting converted into electricity. Now, leave the large switch on the left set to lights and move the smaller switch on the right up to halogen light bulbs. Now, as you start to pedal the bike, notice that the halogen light bulbs start to light up instead of the LEDs. You'll also notice that it is much harder to light up the halogen light bulbs than it is the LEDs. This is because they require much more electricity to turn on. The reason it's harder to pedal with these incandescent light bulbs than it is with the LEDs is because incandescents are an older design. They need more electricity to work. The LEDs are newer. They don't need as much electricity, meaning they're more efficient. They don't need as much electricity to put out even more light. So now you understand why it's much cheaper to run LEDs in your house as opposed to incandescent lights. So now you can go home and tell that to your parents and they can save money. Now let's learn about the battery charging side of the circuit. Switch the large switch on the left over to setting 2 to activate the battery charging. As you begin to pedal slowly, you'll notice as you look on the solar controller that the arrow on the left is empty, meaning that no power is going into the battery. Why is that? Well, the voltage being produced is only 7.3 volts. We have a battery that runs off of 12 volts. As you begin to pedal faster and possibly bump up the gear so that you can turn the generator faster, you'll notice that the voltage you're producing is up at 13 volts, above that 12 volts of the battery. Now, you'll see this arrow on the left is blinking, meaning that power is going into the battery and you're charging it. You can also see this and the battery capacity indicator as the battery is shown to be charging. Now that the battery has power, you can use these AA battery chargers to charge rechargeable AA batteries. You can use those AA batteries in the Xbox controllers at the Boys and Girls Club. You can also use these USB ports to power anything that comes from USB. You can also use this USB port back here that allows for faster charging for your phone or iPad or other devices. Thanks for watching this video, and thanks for using our exhibit. Now you know how to use it, and you know how your mechanical energy is getting converted into electrical energy. And now you know how to use that electrical energy in a useful way.